Hey gang, we are on our next lesson here. So these first three lessons that we've done kind of build on each other. The first one was learning the angle relationships. The second one was when we had parallel lines. What did that do to our special angle relationships? Now today we're going to do kind of the opposite of what we did last time. So last time we were given lines are parallel and then we could figure out what angle measures were. Today we're flipping it. We are going to have the angle measures and we get to decide if lines are parallel or not. So we are proving if lines are parallel based on our special angle relationships. So this is what your notes should look like, something like this. And we will get started. Okay, it says you can prove lines are parallel by using the following reasons. So the first one is corresponding angles converse. So when in math or kind of in logic, if you plan to be a lawyer one day, this is something we skip that hopefully we get to at the end of the year. It's kind of like a reasoning and logic unit. But when you flip the order of a sentence, it's called the converse. So the second part comes before the first part. So the other day, whenever you watched the last video, I'm so sorry, you guys, it said, if lines are parallel, corresponding angles are congruent. Now we're going to flip the order. So now we're going to say, if corresponding angles are congruent, lines are parallel. That's a converse. We just flipped the order. So why do we care? Let's look here. So if we have lines are cut by a transversal so that corresponding angles are congruent, then those lines are parallel. For example, here, if angle 1 and 5, those would be corresponding angles. So if those were equal, L would be parallel to M. What's another pair of corresponding angles? We could do 2 and 6. You could also have what, you guys? Angles 3 and angle 7. And then our last one would be what? Angles 4 and angle, not 5, I was gonna write a 5, 8. Yes. So if any one of those pairs were congruent, that would prove to us that line L is parallel to M by the corresponding angles converse. Okay, let's try the next one. If two lines are cut by a transversal so that alternate interior angles are congruent, then those lines are parallel. Again, if you were given this picture and we had a pair of alternate interiors, so that would be angles 4 and 6, or angles 3 and 5, if we were to know those are equal in measure, line L would be parallel to line M. Okay, let's try the next guy here. Our alternate exterior angles converse. Words are hard today, you guys. So if two lines are cut by a transversal so that your alternate exterior angles are congruent, then those lines are parallel. So what are our alternate exterior angles in this picture? We would know that angles 1 and 7 could be an option, or angles 2 and 8. And then again, our odd man out here, the consecutive interior angles converse, states if two lines are cut by a transversal so that consecutive interior angles are supplementary, meaning they add to what? 180, yes. Then those lines are parallel. What are our examples of consecutive interior angles here? Well, that would be what, you guys? 4 and 5. Agreed. And also what? 3 and 6. Beautiful. Okay, let's look down here at this practice example. Will we fit on one screen? We'll get close. It says, given the following information, determine which lines, if any, are parallel. State the converse that justifies your answer, aka state what kind of angle pair they are. That's all that means. So if we look here, angle 2 and 4, those would be what kind of angles? Corresponding, and they're telling us they're congruent, which does give us parallel lines. So now the tricky part is which lines, because it looks like we have 2 pairs of parallel lines. So do you guys notice how there's nothing happening down here? Like I know nothing about these because 2 and 4 aren't down there. So kind of cover it up with your hand. That kind of helps you decide what lines are parallel. So if we keep that covered up, then we would know that what line, this guy, which line's that? C and D. C and D would be our parallel lines. I don't know if that confused you all or not. I will go over examples like this in class. Corresponding, angles, converse. Okay, 5 and 10. What kind of angles are 5 and 10, if any? I hope you're thinking alternate interior, because that's what I'm thinking. And they're telling us they're congruent, so that does give us parallel lines. So which lines? A and B. A would be parallel to B. By alternate interior angles. Measure of angle 6 plus the measure of angle 10 equals 180 degrees. 6 and 10, where are they? Ooh, right here. Do we have a special name for these 2 angles? Those would be our consecutive interior. We want them to be supplementary, which they are, so yes. Consecutive interior angles. Now, which lines are parallel? A and B. A and B. Remember those 2 vertical lines being parallel? I don't know if you remember that or not. Just a fun little side note. All right, angles 1 and 14. 1's right here, 14 is right there. Those would be alternate exterior. So that would make which lines parallel? That would make lines A parallel to B. (14) plus the measure of angle 15 equals 180. So those guys are right here on this bottom part. Those are consecutive interior angles. Which makes which lines parallel? In this case, it would be C is parallel to D. Angle 11 is congruent to angle 16. 11 and 16. We do have a special name for those. They're not anything that prove lines are parallel, because these are vertical angles. So no lines are parallel, because vertical angles do not show lines are parallel. So no lines are parallel, and we can say nothing because there's no converse. Nothing works. If you want to give yourself a reason to why it doesn't work, you can put vertical angles. But it's not proving anything. That doesn't show us parallel lines. Angle 4 is congruent to angle 15. 4 and 15. Opposite sides on the outside are alternate exterior angles, which makes lines A parallel to B. And then I think I'm going to leave these bottom 4 for you and I to do together in class, just so I just don't know if we know what's going on. And I just don't want to waste all these examples that we could do together in class. Okay, flip the page. Let's see here. Let's see what's going on. It says find x so that line A is parallel to B. State the converse used. That is easy peasy for us to do. So on this first example on the left here, we are wondering what kind of angles these are. So you should hopefully be thinking alternate interior. So alternate interior angles. Okay, what do we know about alternate interior angles? Well, we should hopefully be thinking that they are congruent. Yep, so we can write 10x minus 23 equals 137. And now we just solve. Add over your 23, so we have 10x equals 160. Divide by 10, x equals 16. So what converse did we use? Well, we said they were alternate interior angles, so now we can just write the word converse next to it, because that's what we used. Okay, last one for our notes today. What kind of angles are we dealing with, kids? We have what? If they're on the same side on the inside, these are considered consecutive interior angles. So now, oops, sorry guys. So now we're wondering, consecutive interior angles, are these equal to each other or supplementary? Remember, these are the odd guys that do indeed add to 180. We add our like terms, 96 minus 30 is 66 plus 6x. Subtract over your 66 and we should get what? 114. Divide by 6. 114 divided by 6 is 19. So we found the value of x, and we use the consecutive interior angles converse. Okay, folks, thanks for tuning in to our video lesson. I will see you when I see you, whenever that may be. Enjoy the rest of your day, and we will talk soon.